right then. Go ahead and get going. Any questions from anything that we've done before, or the homework or anything like that, before we start diving into our topics for today? What? The ones I sent out yesterday? Yeah. The one where you worked with an array? Yeah. Yeah, that one was a little more complex than the existing stuff that we've done, right? So let's, I can't remember exactly what I said it was supposed to be called in there, but do you remember the name of the function? All right. So let's go ahead and just live code one of these up so that you know what we're doing. All right, so we've got a basic function here, right? That's fine. And what should we call the parameter to our function that we want to pass in? Because if anyone remembers, if anyone missed the homework or didn't see it, what we're looking for in this assignment was basically it will take an array. So I'll put some comments down here to show sort of the expected behavior. If you call get all odd numbers and you pass in an array, 7 or whatever, then what that should return is a new array that just has the odd numbers in it. That's rough. I mean, that's pretty much what we're looking for here. So we know we need to take a parameter, right? What should we call it? Array? Array is okay. I avoid it, although I don't think it should cause a problem in this case, because in JavaScript, like I said, there's certain keywords, and you can look those up pretty easily. Like if we hop over here and we look up JavaScript keywords. Thank you. So look reserve. Fast. So speedy. You can see this list of sort of reserved words. And I guess, I mean, array isn't on there, but there is a built-in and so I tend to avoid sort of reusing that term so it doesn't get confusing. So I'd probably call it, I mean, numbers, I don't know. We got an array. We're going to want to step over it. We've written stuff like this before, just not in a function, right? Iterating over an array. So what's the stuff that we need to iterate over an array? All right, yeah. And then we need, how are we going to step over it? You need to put it inside a while loop or a loop of some kind. I only introduced while loops to you. In this case, yeah, I'll use a while loop, and then maybe I'll introduce a concept of another way to do loops, but we've really only worked with while loops. So we're doing this while loop. Remember, each loop needs two things. It needs a condition to check. So what are we going to check to see if we should keep running through the loop? Well, what we're trying to do with this loop is, I'll even put a comment here so we're clear. Iterate over each item in the numbers array, right? That's what this loop is intending to do. So right now, how would we make sure that we step over each item in the array? That's then, yeah, there we go. Numbers dot length, right? And then, like you said, and you already nailed the other part, we need to make sure that we change that condition in our loop so that we don't get stuck in an infinite loop, and that was just index plus plus. Now I've got a basic loop. It's stepping over stuff, and we can sort of build this up piece by piece, right? So here we want to do some other logic of some kind, right? And in the second assignment I gave, one thing I suggested was maybe you can just reuse the function that you wrote the first one, which was just is odd. So let's step back for a second and let's create that function, is odd. This will just take a number, not an array of numbers. And how did anybody want to help me out on how you solve the is odd function or what you wrote for it? So if we passed in a number, we want to return true if the number is odd and false if it isn't. All right, so you return number %2. That gets you, I would say that's really close, and in most cases you're not going to get hurt by that, because what that will return, if people remember, anyone remember what this operator is called? Yeah, it's one you don't encounter much outside of programming, so. What? Yeah, it gives you the remainder. It's called modulus, the modulus operator. And what it'll give you is the remainder. So we can easily, like, let's fire up this and let's just see what happens with some numbers, right? If we do 1 mod 2, we get back 1, and 2 mod 2, we get back 0, and 3 modulus 2, we get back 1. So that's awesome. We're getting back a number that works, you know, a 0 or a 1, and 1 we're getting back for anything that's odd, and 0 is what we're getting back. So if we did 4 modulus 2, we confirm it for anything that's even, right? Because it makes sense. If it's divisible by 2, you're going to get back no remainder. Otherwise, you'll get back 1. So this is 0 or 1. Now, the reason it probably worked, if you were or wrote is odd this way, is because 0 and 1 happen to be falsy and truthy. If we remember back to the concept of things that aren't quite false and aren't quite true, any number that's not 0 is truthy. So like, I think this works. 1 equals true is true because it coerces that 1 into a Boolean, and that sees that as truthy. But 0 equals true is false. 0 equals false is true because 0 is falsy, which is why you can sort of get by doing that if you only ever use it in an actual Boolean comparison. And I think you just pointed out a gap in my actual testing, because I should have checked to make sure that actual Booleans came back.
I did it like after it went through that. Well, I set that number as a variable, yeah, like the major.
Like this?
Yeah, and I said if it was greater than 0,
okay,
then it was like false, true because it's odd.
Yeah, that works great. Return true, else return false, right? That's awesome. And there's a lot of different ways to write this. If you guys want to later, we can come back to this and I can show you, you know, a half dozen different ways to write this same function, including some new ways or new bits of code that are really just shorthand for some of this. So now we have an is odd, and I'm feeling pretty confident that that's going to work correctly for us. I could test it if I want to. You know, I'll take this code, I'll copy it down into my read eval print loop bit here, and I'll put some numbers in to test it. Like if I pass in 1. All right, I'm feeling pretty confident. So if I have that, Now inside of my while loop, what should I do when I'm trying to iterate over my array and return a new array of only the odd numbers? So if let's assume we passed in an array, which is just like 1, 2, 3. Just the array 1, 2, 3. Let's step through the code and think about what we would do as we're going through it, right? So we call get all odd numbers with the array 1, 2, and 3. Our index is 0 to start with. We're going to iterate, so 0 is less than 3, so we're good. Now, what do we want to do in here to check the item at array of index 0 to see if it's odd? We can call our isOdd function. And what we pass into that? What will be the argument that we use when we call isOdd? What are we checking if it's odd? Numbers, but we can only do one at a time as we loop through it. So numbers of the index that we're at right now. Does that make sense? Okay, so this should return whether or not this individual number is odd. That's fine. Now we can either work with that directly, or if we want to, we can assign it to a variable. Var test, if you will, like this is what we're testing. So if we assign it to a variable for this index, now we want to do something if it's odd, and so if test, right, which should return that's now holding true if the number that we're at right now is odd. And what action do we want to take? This is sort of the tricky part. It requires thinking both inside of your loop and outside of your loop. So it requires building something up a little bit, right?
I made an empty array and then I put to that array.
You made an empty array, and then we pushed onto it. So let's say odd numbers dot push, and we want to push or we want to push the actual number, not test. So numbers at index, where we're at right now. Okay. So let's see what happens there. Okay, we've got this. Now, one thing we're going to need to do from this get all odd numbers is return a value of some kind, right? So that we return something. So I'm guessing what you're thinking is we want to return like odd numbers. Okay. Let's give this a go and let's sort of see what happens. And actually, I'm just going to console.log get all odd numbers 1, 2, 3. Let's make it simple like this, right? Let's step out of our console here, and we'll call this nodes scratch.js. And what do we get back? It looks like we get back an array that only has 3 in it. But we would expect, we're wanting to get back an array with 1 and 3 if we passed in 1, 2, and 3, right? So now you say, all right, what's going on? What's wrong in this code? So maybe we can do something like, let's maybe put some console logs in here to see if we can figure out what's going on. So let's put one right here after odd numbers. Console.log. I'm going to use a slightly new syntax here just because I'm being lazy. You guys can learn this if you want. This is known as a string expression or syntax. So it allows me to not have to use like plus to concatenate a string. I can insert variables in the middle, and you do it using this backtick character, which is up top left of your keyboard. It's not something you guys have to use, but it's a really nice shorthand that's in newer versions of JavaScript. So we can say odd numbers before adding new one. And it's sort of the syntax that you use in this case. Don't get too hung up on that. It's just a little shorthand for me. Again, you guys could use that syntax if you want. Just like means I don't have to do like the plus and stuff to concatenate a string. I can, using this $ and curly braces, I can shove variables, print them out in the middle of a string very easily. And then let's maybe add one here too, right? Let's do the same thing. So right here, oops. Odd numbers after adding a new one. All right, so let's throw some console logs in here and see maybe if we can get some more information about why this didn't do what we wanted it to do. Okay, so odd numbers before adding a new one, and it's a little that I guess by using this version of the syntax I use, you don't get to see that it's an empty array, but that's what that maps to. That's an empty array. You know, I can convert this back over to the syntax you guys might be more comfortable with, and you'd see it, I believe, more clearly, but I wouldn't worry too much about it. So we have an empty array, and then we have an array with the number 1 in it. Okay, so I'm assuming that's the first time, so that's when our index is 0 and we're at 1. We run through it again, and the next time when we have 3, because that's when our test is true, is for 3 next. It says odd numbers before adding a new one is an empty array, and then it has 3 in it. So can anyone figure out why that's going on that way? If we step through the code, let's assume that we've stepped all the way through. We've already got 1 in odd numbers. So now we've incremented our index. We're at index 1. We test. It's not odd because the value there is 2. So we don't go into our if block. All right, index is now 2. We'll test this value, which is 3. That's odd. So now we're going to go in. So now what we're going to do is assign an empty array to odd numbers as our first step when we do that step of 3. Well, what that did is override anything that we had in the odd numbers variable before with a new empty array. So it doesn't hold on to anything else because we're assigning it an empty array right there. Each time that we come into this loop, we're reassigning it to an empty array. So we can't, the sort of gotcha here is we can't, you don't want to reassign or redeclare or set up this odd numbers variable each time inside of the loop. You need to do that outside of your loop and then just add stuff to it in your loop. Which means it works much better if this is sort of declared up here outside of your loop. And now if we run it, we can see that we're getting back an array with both of the items in it. And that's because each time we went through the array, we didn't redeclare a new empty array for that odd numbers. We just added something to the one that was declared up above. That makes sense? Why that worked that way? All right. Any questions about that? Like I said, this is where I find every time, this is sort of the point in time when we're building this type of function and stuff that a lot of people start getting hung up. Yes?
Can you go up to the stuff?
Yeah. You good? Did you get that?
I have a problem connecting to the network. The only one I found is a AU main. What's the password?
So the password is, I believe, American Underground, capital A, capital U, and then you'll get your Sophos prompt after you've connected, and that'll be AU guest, all lowercase. Okay. Cool. Any other questions on homework or anything else? We'll go into our new topics today. What?
I have a question.
Yeah.
So like, I think that sometimes when I'm trying to write a code, like for the arguments, like this array thing, I didn't know, like naming things for the arguments. Like for the array, I was kind of lost. Like what? I know the like you input an array, but how do I put that for the function? I was kind of thinking.
Yeah, because these were the first ones I think that I didn't give you the arguments for, or the assignment today, right? Where I left just a comment in there to say add your argument. I mean, it's pretty simple. It doesn't matter what you call it, as long as it's not like a JavaScript reserved word or anything like that. But the way a function works in that regard, and we can, let's just create a simple one, like function foo, and it's not going to do anything at all. But the arguments just, when you're declaring it, they go inside of your parentheses here, and you can name them whatever you want, and then put them in a sense whatever order you want. The only thing that matters about order is that when you call that function, you have to pass your parameters or pass your arguments in the same order as the parameters are defined. So let's say foo takes a number and a word and I don't know what else, a sign or something. You can just give those, you can name them whatever you want them to be. It's just like naming a variable, except you don't have to say like var number or anything like that. And then the only thing that matters is when you call foo, you can see it's telling me foo takes a number, a word, and a sign. So then you have to pass in your arguments and call them sort of in that same order. So if something has, like the way most of our stuff that we've done so far, it's like one parameter. So then you just need to basically define one thing up here, and you don't have to do any, the comma or anything else. Does that make sense? Does that clear it up?
Yeah.
Yeah, it doesn't, like name doesn't really matter. You want to use meaningful names. But it's not something that external to that function anything knows about. It's only internal to that function. Any other quick questions before we dive in? Oh yeah, we're gonna get into recursion in just a second. That's our lesson for today. So today, the two main topics, recursion, which will probably throw you for a loop. It's confusing. I think it's a fun topic to introduce, and I think people should a little bit avoid. I think it's useful, dangerous thoughts about how functions work or anything like that. And then we're going to get into the last major topic for really programming topics that we're going to introduce, which is objects and object-oriented programming. We're still going to be having to go over that again next class, and everything we pretty much do from now on will be building on all of these existing topics, just building more complex things, other ways to work with these items, how to combine them in different ways. Yes? We have, I think 3 weeks left, I believe, so the 26th, I believe. So should be the last class. It's going to be whether I get through everything I want to cover or not. So we'll see what we get done by then.
The next one, so will the next one be here? Or?
When does the next? I don't know. Probably here. You mean the next, not the very next class, but the follow-on course or whatever. Yeah, it'll probably be here. Probably, we don't know exactly when it'll start yet, but we're hoping, late September or something like that. So. All right, so the first new topic for today is recursion. This isn't really a new topic. This is just a combination of things in a way that you may not have seen it before. I have this horrible joke here. The call came from inside the house, or function, right? It's like a bad horror movie, right? Like they answer the phone and they're like, no, they're inside the house. That's sort of like recursion. And recursion is just, well, first, we've seen an example, and we just used one with isOdd, right? Of a function being called inside of another function. IsOdd was called in the, get all odd numbers or whatever. And here's another very simple example. Like we've defined an add function and a product function, and then we have an equation function that calls add, and oh look, I have multiply. Look, I've got this wrong. Fix my own thing there, right? That calls add and product inside of it. So it's easy enough for a function to call another function. That's not very complex. What's interesting is a function can also call itself. So you're not just limited to calling other functions. A function can call itself inside of itself. So we're going to go ahead and take this code, move it over here, and then we'll work with this for a little while. So this is a function called factorial. This is probably one of the most common examples of recursion that you're going to encounter when you first learn it. And does anyone know what a factorial is of a number? So if yeah.
Is this the exclamation point where it's like 5 times 4?
Yeah. Yep, that's what a factorial is. So if you have the factorial of 2, it's just 2 times 1. And 3, it's 3 times 2 times 1. And 4, so it's that number times every number that's less than it. So if you wanted to do that, and you could write, in fact, in a sense, I might write this as a loop too. Fact loop, right? But it might be, this could be a little bit of a challenge. I don't know if we want to try and work through this together, but if you're trying to write a factorial for a number as a loop, how might we go about this? We want to try and build this out. Var, we know we're going to need a total of some kind, right? That we compute. And all right, we're doing a loop, and really the only loops that I've shown you guys so far are while loops. So let's use a while loop. Index equals 0. So while, well, let's actually go another way because you don't always have to count up. Index equals n. So then let's say while index does not equal 0, we're going to do something, and then what we're going to do is remove 1 from our index, right? Lower our index down because we need to be approaching that exit, our condition. So we're changing our condition. And we can just take our total and total times whatever our current index is. Then we could return total. And there may be a problem with this, I don't know. I just wrote this on the fly. But does this make sense to people if we were trying to compute the factorial? So what we would do is, okay, let's test this out if we pass in 1. So we pass in 1, our total is 0. Oh, we got a problem, don't we? I can't start with a total of 0. I would start with a total of 1 because I'm multiplying each time. If I multiply by 0, I'll always get 0. So our total is 1. Our index is 1. Index isn't 0. So the total will equal 1 times 1, which is 1. Index goes down to 0. Our index is 0, so we return. And we could even make this a little more safe so that we don't get stuck in a loop if somebody passes in like a negative number. We could say, while index greater than 0. So it's sort of guarding against that. And then if we did this with 2, we pass in 2. It should be pretty straightforward, right? We start with a total of 1. Index is 2. So 1 times 2 is 2. 2. We decrease it. Then 2 times 1, because we've now multiplied it, is 2 still. We decrease it, and now we return our total. People feel pretty comfortable with this, the loop version of the factorial? Yeah. You kind of get it? Okay.
So n is whatever number you input, or?
Yeah, n will be whatever you input because that's just the. You don't always have to start you don't always have to loop from 0. You don't always have to start an index at 0. You can set it anywhere you want. I just chose some different values here because it works pretty well for this factorial. So we can test this, right? Let me comment this line out. Well, let me uncomment, copy it, comment it out, put my copy here, back loop like 5. And we can see if it runs, and we get 120. So So that worked just fine. But recursion allows us to write this a different way. So with recursion, we can call the same function that we're in. And this is a little tricky when you're walking through it, but we're working with recursion. If we pass in 1 for the factorial, that's what we want to compute the factorial of, then, okay, n equals 1, so we just return 1 and we're done. That was really easy. And then let's try it with 2, because that's where we start to see the complexity here. So if we pass in 2, n doesn't equal 1. So what we're going to return is n, which is 2 right now, times the factorial of n minus 1. And n minus 1 is 1, because it's 2 right now. So we're calling factorial of n minus 1. So it'll go up here, and factorial of 1, n equals 1, so we return 1. So then we get back 1 times 2 and return that value. So if we're working with this, let me scratch this out in a sense of what this would look like if we did it with 3. And here's how the computer would sort of evaluate this, right? So factorial of 3, we're going to go to the else because n doesn't equal 1. So then what we're going to get from that is return 3 times factorial of 3 minus 1, which is 2. I'm just going to do the shorthand of those. But it can't evaluate this whole expression yet because it still has something that it has to evaluate that isn't a constant yet. So it still has to expand that out. So really what it does is return 3 times, and if we called factorial of 2 and we're evaluating it, well, n still isn't 1, so we're going to return n, which is 2 times factorial of 1. All right, we still haven't reached a case that where it's just these constants that we can work with. So we have to evaluate this factorial of 1 expression first. So then we're returning 3 times 2 times, and the factorial of 1 is just 1. So now we have an expression we can actually return, because we can multiply 3 times 2 times 1. And that's able to return 6. Another way to write this out, if you're thinking of it, you know, when you're thinking of it, another way to write this sort of second line could be like this. Return 3 times like 2 times factorial of 1. You're sort of breaking it down step by step. This is probably confusing right now. What? That's recursion. The idea of the recursion is calling yourself again. But I'll prove to you that it works, right? Because this time we're calling this recursive version of factorial. And then, you know, this isn't going to be something that we're going to do too much of necessarily. I don't even know if I might give you a very simple recursive homework problem, but nothing too complex. And actually, even if I do, I won't write the tests to verify that you use recursion. If you choose to use a loop or something, you can. I'll just encourage it. But one of the awesome things about recursion is we can actually show mathematically that anything that you can do inside of a loop, you can also do with recursion. And in some cases, not all, but in some cases, it's much easier to reason about something when you're calling that function recursively than it is if you're trying to work with it inside of a loop. So sometimes it's just a lot easier to think about what's my base case that I need to solve, and then what do I do for each other case to call back to myself, and solving a problem that way.
That basically the complexity of the problem is that just some program needs to be solved.
Nothing has to be. I think you could write it all out with a loop, but there are definitely times where you have a much more complex implementation if you go with a loop or something like a loop versus a recursive function. A very classic example of that is known as the Towers of Hanoi problem, which did anybody as a kid ever have the little stacking rings, like the big one, and then they get smaller and smaller, and you sort of stack them up, right? So that's sort of the basis for a classic programming problem. It's called the Towers of Hanoi problem. Let me pull up a site that. See, here we go. The idea is that you've got this set of stacked rings, and what you're trying to do is move all of them from one stack to this far one stacked the same way. So you want them stacked from largest to smallest over here on this far side. And the way you end up doing it is this sort of step-by-step process. And I think actually you're never allowed to ever put a larger disk on a smaller disk is the other constraint of this. So if you're watching like this, we've got a little animated solution here that shows it working through where you can move the smaller disk over, then you move the larger disk here. Okay, now I can move the smaller disk there, move this one here, all the way back. It's this very intensive step-by-step process. And if you were to write a solution to the Towers of Hanoi with loops and not recursion, it would be very complex to write this solution out. But it's actually pretty simple to write out a solution to this using recursive algorithms. I wouldn't ask you guys to try and solve that right now, not for just one of these homeworks, but if you're really interested in a challenge, something that would really push, give it a go, there's going to be plenty of answers out there online for how to solve that. So it's not like you're going to be stuck or not being able to get somebody else's solution. But it's a really good example of the type of problem that's solved way more easily with recursion. So another example, and this is just another example of recursion, is if we have a couple different looping functions here. So we've got a sum loop, and I did this one as a loop variant. And these ones we're each going to take an array of numbers, and we can also implement the same thing recursively. So this loop, okay, we get the array of numbers, we've got our total, we've got our index. This should look very, very similar. The same code we've done several times now. We add our current item to our total, and then we return it. And in a recursive version, we could do something like this. We pass in our array of numbers. We pop the last item off of our array. So we have that. Okay, now if our length is 0, because we just took all of the items off the array, there's nothing left, then just return the item that we just took off. But if our length is more than that, return whatever item we took off plus the sum of the rest of the numbers. And you might be, there's one bit here that's slightly tricky. It's also interesting that this has a side effect, right? This sum recursive has a side effect. Does anybody point out what the side effect is of that?
What do you mean by the side effect?
So I'm going to go ahead and, oops. I blew my development environment up. All right, let's try this. I think this will work. There we go. So I defined both those functions in here. So let's say I create an array of numbers equals 1, 2, 3, 4, 5. And if I call some loop with numbers, I get the result out. And I'll get the same thing with the other one. There was a side effect, which is the side effect is connected to the last topic we covered in class last time. Does anybody remember what that topic was? It was the concept of passing by reference as opposed to passing by value. Does anybody remember what happens when you pass something by reference, which is what happens with like arrays? What? Scope, sort of. Everything that has a reference to that object refers to the same thing. So unlike when you pass by a value, if you change the reference inside of a function when passed by value for like strings, it only changes the one local inside of that function. Whereas when you pass by reference, it changes everything that refers to it. So the interesting thing here is if I run some recursive numbers again, we get undefined. And that's because the numbers array is empty. And the numbers array is empty because each time I looped through this, I popped an item off of that array. So by the time I'm done with my recursive version of my sum here, there's nothing left in my array. And since it was passed by reference, the numbers array that this function got is the same numbers array that exists in the global scope outside of it. So the side effect is that it sort of emptied that array, right? Whereas the sum loop did not, hence why I was able to call sum recursive after it, because it just sort of iterated over it, looked at the numbers individually. It didn't change anything in its array, in the array. I sort of put that in there because you'll probably make a mistake like that, where you, in your code, you're sort of iterating over something, and you think that you're working with it, and you get out and you're like, what happened to my object? Where did it go? Where did my array go? How did something change? Those are the type of gotchas that'll crop up when you're working with stuff like that. All right, any questions or anything? It depends. A lot of times for reproducibility, you try not to have a side effect like what I just did, because it may cause something to change that you didn't intend to change and somebody else doesn't expect it to change, right? But sometimes you do intend for like a function to change something outside of it. And that's why when I introduced functions, I said some functions are, there's a concept of a pure function. And a pure function takes some information in, returns something back out, and doesn't change anything outside of that function. So it doesn't modify anything that came in. It can do whatever it wants internally. It could create its own copy of that array and work with those values. It can do, something entirely differently. It can create its own objects inside, but you don't want it to change anything externally if it's a pure function. Every time you call it, you get this very strong aspect of reproducibility and not creating side effects. Sometimes, though, you intend to have a side effect. Some functions do that. It's just useful to know that that can happen. All right, if there's no questions, if people want to take a quick break before we talk about objects, that'll probably just be the rest of the class. We'll introduce objects. If anybody wants, again, if anybody wants a piece of candy, I've got some candy up here. Wanted to bring something. Plus, we're going to use them as physical examples of objects to talk about. So, because why not? It's a lot more fun than talking about animals and cars, which we'll probably do as well. You put your hand up. Do you want something? You're looking at it. See, you're eyeing it, but you're like, I'm not going to go over there and grab it. I see that.
Can you put lesson 8, lesson 9 notes on?
Yeah, sorry. I haven't uploaded them yet. I forget to do that sometimes. Let me get what I have right now for them up. In fact. All right, those should be up now. What?
Where are you doing that?
What? So
You're at the computer, or are you doing that online?
I'm doing them on my computer. I'm using something that you'll learn about in the next course. Not really going to introduce it now, but when you're working with code, we tend to store everything that you use in something called a source control tool. So who here has ever written like a Word document and then saved like version 1 and then save as version 2 and then save as version 7 and right? Yeah, we've all done that. And it's annoying. And you do it because you want to keep around each version of what you've done and track it. And for software development, that would be a nightmare if you had to copy all of your code to somewhere else and say, this is version whatever of this code, especially when you've got a lot of people working on the same code. And so we created software that helps manage that. And I mean, I think it would be really cool if it got used elsewhere, but who uses like Dropbox, for example? Anyone use Dropbox? Anyone ever gone on there and looked at the like history of a file and you can see every change that's been made? It stores them all for your files if you go to the web interface. That's sort of what version control does, is you can say like, I made all these changes, push them to my source control tool and treat that as a version. And instead of you having to keep separate copies of it, that tool tracks each copy. So if you ever need to go back and get an old copy, you can go back and get it out of the tool, but you can act like you're only working off one copy of it. Yeah. So that's what I was using. It's something called Git, which is a distributed version control tool. And so I make the changes locally and then I push them up to GitHub. Yeah. All right. Took a break. Time to dive into objects. I had this in my Ruby class, and it's not quite as relevant, but you know, it still somewhat applies. So when you start getting into objects and object-oriented programming, it's going to be objects everywhere. In some languages, Java or Ruby, for example, everything is an object. There's nothing that you interact with that isn't an object. So in those languages, like even numbers or strings are actually objects. In JavaScript, that's not the case. But objects are a very fundamental aspect of working with any of these modern languages. So it's, you know, time to introduce these, like what is an object? How do we work with them in JavaScript? And then we'll keep building on that. And the definition of an object is just an entity that has properties. An object is just an entity, any entity, although they're a specific type in JavaScript that has properties. And an object encapsulates state and function in its properties. So the properties both capture state of the object and function of the object. State are like characteristics of an object. So we'll definitely have some examples of this just a little while. And function is behavior of the object. You probably heard me use the word methods. Methods are functions defined on an object. They can be performed with that object. So that's really like that's what an object is in any programming language. And the idea is to give you something that maps back to more like physical real world ideas. So when I'm introducing objects, I like to spend a little bit of time just trying to work with some real world ones before we, get into the code ones, so that it makes a little more sense. So I'm just gonna toss this here. It's an object. Can you describe a property of that to me?
It's round, it's soft. We have reports inside.
All right, you want to throw it to somebody else? Can you describe another property of it?
It's soft. It has a purple and blue texture.
Great, yeah. Throw it to somebody else, anyone. There we go. Can you describe something else? Great, awesome. You want to toss it to someone else? Let's see if anyone can get something else about it.
Maybe we have some cotton, make it,
Maybe.
yeah.
All right, yeah. That's awesome. Oh, it's getting harder. All right, yeah, it's got a size, right? You can toss it back up if you want, or somebody else can give it a shot. But this is, we're used to working with objects, right? This is something that we've done our whole life. We just don't tend to describing them with all of these properties. But that's really what we're doing in object-oriented programming. There's one other aspect of object-oriented programming that's a little different than working with objects in the real world, and that's that we also attach behavior to them, these methods or functions, action. Whereas in the real world, you don't, an object doesn't usually have its own action, something acts on it, right? Like if Axel were to throw the ball or whatever, that's an action acted on it. Sure, yeah, you can throw it. Yeah, go ahead. That's an action acted on it. But in object-oriented programming, those tend to be on your object itself. And so that would be like a throw method. And we'll get to see that. I don't know if we'll get too far into methods today. I don't want to spend too much time on it. So we've already started working with objects. Even though you guys haven't created any or anything else, we've been working with them pretty much since the first day. And just some of the objects that we've interacted with already in our code have been the math object, where we've used it to get random numbers, console object, and the array object, for example. Now, you may not have known you were operating on an array object, but I can, oh yeah, wrong. I can help show that by, if we pull up Node and we like create an array, and then we do type of R. I don't know if people remember, but it returned an object instead of returning like array or something. That's because it's actually an object. It's just a specific type of object that we have some shorthand to create, which happens to be this sort of array syntax. But we can also validate that these other things are objects too. Like we had this math, like we did math.random, for example. Math is an object. And type of console is an object. So they're just this other type, just like, what are some of the other types we've encountered already in JavaScript? Types. Yeah, what are some of the types? Boolean, number, string. That would be Boolean, but the other two are tricky. Undefined and null, right, are also types. An object is just another type. And once you've got that, and I believe functions, you've pretty much captured all of the types that exist in JavaScript. So that's why I said this is really the last major concept. This is the last type. So let's start creating objects. There's several ways to create objects in JavaScript, but the easiest by far when you're just learning is the object literal syntax. So that's what we're going to start with, and we'll learn the other syntax in the next class. Object literal syntax is very simple. If you look at it, you might say, boy, that looks a lot like, say, creating an empty array or something. There we go. I created a a car object, and we can verify that by checking the type of car. So the only difference between that and an array for creating an, in a sense, empty object or an object without properties is for an array you used square braces, brackets, and for an object you used curly braces, just like you've used on functions or if blocks or anything else. It's these curly braces that sort of define your object. So that's just how you create an object. Now, an object has properties. So the primary concept of an object is it's a type that has properties. Each property is a key value pair. There's a key, and then the key is that property name, and then there's a value of some kind that maps to that key. It can be any type, a number, a string, an array, a function. It could even be an object. When a property is a function, it's called a method. So basically, whenever referring to a function called on an object, it is referred to as a method of that object. For example, we frequently call the log method of the console object. But let's play with this a little more, right? We've called the log method just like we would call another function. So let's test that out. Let's see what the type of console.log is. We're not calling it. We didn't put our parentheses there to invoke it. We're just looking at what the type of it is. Sure enough, it tells us that is a function. And we could look at some of the other ones that we've worked with. Let's have a good example here. We created this empty array, right? What's a property that we've used off of array? How do you check, how do you know how long an array is? Length. Length is a property of an array, right? So let's try that. Type of r.length. And it tells us that's a number. Makes sense, right? Because when we get back a value from it, we get a number. So any property on an object is just a key value pair with the key being the property name, length, log, whatever, and the value being what it actually has. So if we looked at the value of this one, r.length, the value is 0. And if we looked at the value of console.log, so we're not going to invoke it or call that function, we're just going to look at the value. It gives us this little sort of shorthand saying this is a function of some kind. I can't show you that function, but it's a function, right? And we could do the same for if we looked at the math.random. We should get sort of the same thing. This is a function of some kind as well. So that's really the core concept of an object. An object is just a type that has properties. Those properties are key value pairs, and the value for any key value pair can be anything. The key is just the string or whatever it is that you use to reference it. The standard way, so setting and accessing object properties. We've done this object literal syntax. We can set properties on an object when it's created. I've got some long words here. I think it's easier to see than look at the long words. So we're just going to go straight to the example. And you can also access them. And the way you access them, and you guys have been doing this a good deal, we use dot notation to access a property. So if we create another car object, let's make this one a little more complex than our last one. When you're creating an object, the way using object literal notation, the way you set properties or create properties is you give it the property name, followed by a colon, followed by the value for it. It looks a lot like CSS. Yeah, it does, actually. Except you have to quote the values here, whereas in CSS, you wouldn't have to quote the values. And here you use a comma after each one, as opposed to CSS, which would be a semicolon. So this is sort of the syntax, the object literal notation for doing that. And then now that we've created this car object down here, for example, we can look at any of the properties of it just by doing car.color or car.type.
You actually don't have to declare like in class or anything like that. Just
Ah.
like another class.
So I was gonna wait for somebody to ask this. Yes, I meant to mention anyone who's familiar with classical object-oriented programming, so Java, C#, other languages like that, you might get a little tripped up by the way objects work in JavaScript, at least at first. The concept of a class didn't exist in JavaScript until very recently. And the concept of a class that does now exist in JavaScript is actually, pardon the sort of programmer jargon here, syntactic sugar around real JavaScript objects. So what I mean by syntactic sugar is it's just a way to let people who are comfortable with classes create objects in JavaScript and feel comfortable and feel like they know what's going on. But it doesn't work the exact same way as what would be a classical object-oriented language like C# or Java or something like that.
It's easier to describe it nowadays this way. The only thing is like it could be confusing with like any other variable. Let's say this function, you know, you have a keyword functions and then the function name. But here, a variable car, is it describing it? Is it also to get confused?
Yeah, yeah. I think it's a lot easier for somebody who hasn't learned classical object-oriented programming to see objects like this first and pick them up, because I didn't have to teach people about classes. I didn't have to teach people about these concepts, right? And so I think in some sense it's easier, but it's also then a hurdle for anyone who's familiar with the other approach. Yeah, the easiest way to create objects is just this object literal notation. Boom, we created an object.
Then you have this JSON format.
What? It looked a lot like, yeah, it looked a lot like JSON. It's not a perfect map, but it's awfully close to JSON syntax. There's also some flexibility in the way that you create this stuff. Like you can quote your keys if you want to use quotes around them when you define them. And you may have to do that for certain keys if it conflicts with like a keyword in JavaScript. So I generally just try to avoid those, but you can name properties. You can use the same name as a keyword, but you have to do some hoops to jump through and stuff so that you don't have a conflict. Yeah.
I have a question. I don't want to sound like I'm getting ahead of you, but can we declare, can we build a function inside?
Yeah, we can put a method on it. And we'll probably just get to that today. Not much more than that. And we'll get there. So, start to get into this a little more. Object-oriented programming is the terminology used for this stuff. It's OOP for short. So you're going to encounter that terminology a lot. And it's just a way to write programs using objects. That's the way to think about it. So the vast majority of the work we're going to be doing going forward is going to be sort of object-oriented programming style assignments. So objects are going to be this foundational piece of our code, and we'll build on top of that. Then when you're using OOP, you just write, create, and modify objects, and that's sort of what makes up your program. It changes the way a program is written and organized. So far, pretty much everything you've been doing is really function-based or just procedural, var, while, right? We just introduced functions, so you've made calls to functions. Object-oriented programming changes that a lot, and so you really need to be comfortable with the idea of not thinking of your code as a linear thing, like a book. Your code doesn't execute from top to bottom. It jumps around to wherever's being called at any point in time. So once you get comfortable with the idea of function calls and your code can jump around to those, then it shouldn't be too hard to get comfortable with the idea of the way object-oriented programming works. We'll talk a lot more in future classes about the benefits of object-oriented programming, why this was introduced or why it's a useful thing to know as opposed to just doing stuff procedurally. But we won't go too much into it today because it's better to get objects under your belt a lot more before we start talking about why they have value. You'll begin to see it a little more easily. So let's take a quick break and go back to the real world again. And then if anybody wants any more candy, take one. And then if you have one, look at it and try and describe some of the properties of whatever piece of candy you have or did have. If not, describe some properties of this little Twix that I have up here. It's small. Yeah, they call it fun size. What a lie. Fun size would be like huge. This isn't fun size. This is no fun size. Whatever. Anyways. Anything else? Anything. Shiny.
Gold wrapping.
Gold. Right. Well, remember.
Outside, I guess brown outside.
Right? She wants some more. Remember I talked about how a property of an object could be another object, right? So it makes sense that this candy wrapper object has a property of it that's the candy, right? And that's another object itself, which has its own properties and its own characteristics and behavior, right?
So I guess like red lettering. I guess they're red script font.
There you go.
Stroke.
Yeah. So I do this, it's a little basic or whatever, but it's useful exercise. And I think one thing I'll encourage each one of you to do, can't really do it on some sort of verification programming thing, is sometime between now and the next class, just find an object. And I suggest going with something simple. Don't try and go with something too complex. Find an object around your house or somewhere and try and describe as many properties of that object as you can think of. And try and jot them down and take notes of them. And think of them the same way that we've already been introducing stuff here. Try and describe them with some sort of like key value description, like what's like the first thing might be color or something, and it might be gold or whatever, and then it might be like wording on front or something, right? Like try and think of all the properties you can think of for whatever object you choose, and think of what are the properties, and then what's the value of that property. That's because it'll get you in the mindset of working with objects in programming too. It'll translate over as you build and work with objects in code. So we've already got a simple object. Let's go ahead and create another one here. We'll create this redefine our car so that, let me clear it, so that it has a color of black, a type of truck, and a brand of Ford now. You can have it in any color you want as long as it's black. And then we're not stuck with just what we set for the property values when we created an object. We can change them. And the way you change them is the same way that you change any value on a variable. So let's say we want to change our type here. If this was a variable, how would we change the value that was stored in a variable named type? What?
Oh, I think you just call it as it's like a car.
If that was our variable name, how would we assign something new to it? There we go. Yeah. I don't know if you were cheating. See? Right? So I'll take it back real fast, but we'll put it back to a truck, and we can look and see what it is. Like if we do car.type as truck, and then we can change it. So we can change it to a van, and car.type, now it has van as its value. So you can change the values for any properties on an object just by reassigning them to something new. And just like any other variable that we've worked with inside of JavaScript, There's no constraints on that, right? Yes.
See what this is valuable at.
Yeah.
Like Amazon, like when you have certain things that have different, I guess, quantities or varieties of certain things, like I guess pair of shoes on Amazon. They got this specific pair of shoes in different sizes.
There we go.
Yeah, they just modify or just input a different size in there.
I think it's a great example, right? And maybe we'll come back to that right at the end, right? What they might have is a shoe type of object which has certain properties, and they may create different copies of that object with different values, right, for these different scenarios. Or they may change it when it changes. The quantity changed, right? So in this case, our type changed, and we can even, like I said, we're not constrained. This works the same way as any other variables. So if we want to really get messed up, we can say car.type equals false, which, you know, you don't want to do, but there we go. Now it has false. It no longer has the string that we had in there before. Because remember, for anyone who's familiar with other languages, JavaScript is loosely typed, so it's not bound to like a specific property isn't bound to staying that type forever. And here's another one of these fantastic things that's very different for JavaScript versus, say, Java, is objects are not locked in a sense. You can add properties to an existing object on the fly just by using a new keyword. So let's get our Ford truck again. All right, so we've got our Ford truck, and let's go ahead and add another property to it. So car.price, and I don't know, how much does a truck cost? A lot.
Just say 10.
10,000? I think that's low. I think it's like 30,000 or something.
Are we talking about?
Yeah, new truck.
We'll have to add that kind of statistic
Usually,
What?
usually 60.
60? Oh, we're gonna get an expensive truck. This guy's.
That's another characteristic to add, like you can use or new.
Yeah, we can. So let's add it in afterwards, right? But we've just added it. So now if we look at our car object, you can see we've added a new property here. We added a price. And if we did car.price, we get that value out. Now we can try and access a property that's not on there. So you said, let's say is used. State. Car.state. Undefined. Right? That's a lot like when we had an array and we tried to access something outside of the bounds. So if you try and access a property that isn't on your object, that doesn't exist, you get undefined back. Okay, so now let's add one. So this is definitely a new car. Right? We slightly use. Now if we look at our object, we can see that we've added another property to it.
Then you have a new black truck for $60,000.
Yeah, that's an expensive vehicle, man. I don't know how much trucks cost. Probably is reasonable. Probably, who knows? Right? Like, do we want to add another property? Anyone think of another property of a vehicle we should add to it?
How many miles it has?
Miles, mileage. Should be 0, right?
It's a new car.
That's not new though.
That's right. And it's got 0 mileage on it. It's got nothing. Right? All right. So we can just add properties to objects. Now, I'll let you know, this is, again, something that's not the same in every programming language. Some, Java, C#, these sort of compiled languages, you can't really just add properties to your objects on the fly. Everything has to be defined at the beginning. So that's what makes some of these dynamic languages, some of these interpreted languages very easy to work with, and you get to do some really cool stuff. All right, we already talked a little bit about some real world objects. I don't think that's correct. Let me check. I don't know if that's right. I don't think so. That's from my old Ruby notes. I didn't quite get that updated. So let's, I mean, these ones aren't that exciting. These are boring. These are very traditional examples. A car, you know, animals are ones that we use. Maybe we can think of something more fun to work with. We can model anything as an object. Does somebody want to think of something a little more interesting, a little more fun? I know we've had somebody in here who's done like trying to do video games or something, video game programming. I mean, we could do like a video game character, or do you have an example? A bank account? Oh, you think a bank account's fun? Okay. Let's do Pikachu. Let's do this.
That's it. No, when you open it inside.
All right. Let's do this. Let's create a Pokemon. So it's not a Pikachu. It's Pokemon. All right. And because I don't want to have to define this stuff right now, let's just create it like this. So we have Pokemon. Now let's start adding some properties to our Pokemon. So what's the property? Type? What? He's a Pikachu, right? That's his type? What? Oh, so he's like an electric? Okay, so what's his name? You say it's his name? Let me check something real fast, just to make sure. All right. So let's give him. See, I thought those were types. I thought you could catch multiple Pikachus. I didn't think there was just one.
I mean, you can.
See?
There's a difference between his species and like the.
It's like his species. Okay.
Difference between the species
Well,
and the
technically,
type.
type would be mouse.
Okay. Look at me. I don't know enough about Pokemon here. Funny part is, I should have played this video game when I grew up. That is like right in my time frame of video games, and it's one of the ones I never played. Go figure. What? That I didn't play it? I played so many other games. Pokemon, I just never picked up. I don't know. I don't know. So what's some other properties? What? Color? Okay, yeah.
Yellow and white and black.
All right. Yellow and black. Oh, let's do it this way. Do something different, right? It can be an array. Yellow, black. We can add an array to him. So if we look at our Pokemon now, we've got an electric type of Pokemon. His name's Pikachu. It's yellow and black. What are some other properties of our Pokemon?
Brand is like from Japan.
What?
Pokemon from Japan. I don't know.
Pokemon.origin?
Origin.
Japan? All right. Cool. So now maybe let's go ahead and write all this information out ourselves, right? So instead of this writing it out, let's print it out. So let's do something like console.log. We're going to write out all the information about our Pokemon. You have cut and I'm going to use this other syntax so that I can be a little lazier here again. Again, this isn't a big deal. Pokemon.type. Pokemon.name. coloring. This one's a little trickier. Oh. Pokemon.color from Pokemon dot origin, right? Okay. Let's see. Got an electric type of Pokemon named Pikachu with coloring yellow, black. Oh, look, I didn't have a W on yellow. Who's making fun of me for that? Who saw that and didn't tell me? Oh, thank you. Yeah, you guys are kind. Thanks. We're gonna fix that right now. Pokemon.color 0 equals yellow. We're gonna try this whole thing again. We'll just run this console log again. There we go. Fixed it, and we fixed our color. No problem. We're all good. Okay, but let's say, we don't want to have to type this out inside a console log every time. That's tedious, right? So let's define a function that will return information about our Pokemon. Whatever Pokemon we pass into it. So how would we go about this? Function like describe Pokemon or something, right? And then what do we want to call the parameter? Like creature, or I don't know, right? All right. And then we could, I don't know if this cut and paste is going to work. We'll see. I'm going to be a little lazy. We could like return what we had here, except because this is inside of here, we need to refer to it by the creature. That's our object name, right? Oh no.
Every time you put it on an object, you have to use the square.
I messed up my function. All right. Screw up my function. We'll just have to write it all out. So function describe, because I'm getting lazy. Creature. All right. So return view of costs. And maybe it won't all be electric, so let's like put that little n in parentheses. Yeah, I need this at the end. Creature.type, type of Pokemon named. Creature.name, coloring, creature.color, creature.origin. All right. So I should return something, right? So now we should be able to test this, like describe Pokemon. Awesome. This seemed to work. So now if we want to describe him, if we change any characteristics of him, of any of these characteristics, we don't have to rewrite that thing in order to print out that new information, right? We've already got a function here that prints out all the information that we need for our Pokemon. So if we change something, so make him a really crazy Pokemon. His colors are going to change. What are his new colors for this weird Pikachu? All right, so now we have a purple and green Pikachu. If we call our describe Pokemon again, it returns back our string with the new information from our object, because our object changed and it's got what we need for him now, right? So that's awesome. Now let's create another one. Poke2. Pokemon 2. I don't know. So let's give him some of these properties. I don't know. Let's use another Pokemon. Yes.
There is inheritance on JavaScript? Or?
Yeah, we'll get there.
Okay.
Not today, probably, but we will.
Just so like describing another type of the same type.
Yeah. We probably shouldn't have used type, but it's not a big deal right now. But all right, so let's give him, what's his type? I don't know. We're using a different Pokemon. Can anyone describe something other than Pikachu? Is Pikachu all you know? What? Charmander. All right, what type is he? He's a fire? He's fire, right? Pokemon 2 dot name. Charmander. Spell that right? All right. Pokemon 2 dot color. What's his color? Orange. That's all. All right. Pokemon 2 dot origin. Where's he from? Give him a different origin. What? Can't do it.
That's the name. That's where he's from.
Kanto?
No, okay.
Is that where he's from in the games?
Yeah.
Okay, good, yeah. Obviously, I know this stuff. All right, so we can describe this one, right? We pass something different into our function, and we get a different result out. That's awesome. So, I mean, I feel like this has been a good introduction to objects. Let's do one more thing. We won't delve too deep into it, but it'd be really nice if this describe function that we have to describe a Pokemon, if this didn't exist as some separate thing sitting out there that we have to call and pass our Pokemon into. It would be great if, in a sense, a Pokemon could like describe himself. So it'd be really nice if we didn't have to define this elsewhere. So let's, I'm just going to look at this function here. All right, we've got our function describe. I'm going to run it real fast with this. I'll show you, we already talked about how you can set a function as a property on an object the same way that you can with a string or an array or anything else. So we're going to add this describe to, we'll add it to our original Pokemon. Pokemon dot, so this first one, let's just add a new property. We'll call it describe. It's going to equal a function. So this is using, this other syntax. And this is where it gets a little different. When you attach a method or a function to an object, that function can reference the properties of that object. And it doesn't have to do it using the variable name of that object, because that would be really awkward if you had to use the variable name whenever you did that. How could you possibly write a function that worked for any object like that? So instead, when it's trying to refer to itself and get properties off of it, it uses the keyword this. So we can write this almost like we did before, but with one small difference. A, we don't need to pass in a parameter because this is already part of our object, part of our Pokemon. So it doesn't make sense to pass our Pokemon in to it. And instead we can get the properties directly off of him just using the this reference for it. So you have caught this dot type of Pokemon. And you notice this looks a lot like, this is the same syntax as the other dot notation. The only difference is we've got this special keyword this that we're using here. named this dot name with coloring this dot color from this dot origin. All right, and we'll close our function. And now if we looked at the type of Pokemon dot describe, we see that it's a function. We added a function to them. If we look at our Pokemon and just look at all of our properties right here, we'll see that it tells us we've got all of the properties that we had before and this new one, describe, which is just sort of shorthanding here in the read eval print loop telling you this is a function. And we've already invoked functions on other objects, so we should feel pretty comfortable with that. How can we call this function? Pokemon dot describe, that's our key for it, right? And how do we make a call to a function? Parentheses, right? So there we go. Now we didn't have a function that lived outside of our object. We've put this as a method on our object and it can work with our object. So now if we change this, Pokemon dot name equals Bulbasaur. What? I may know a few Pokemon names. I played Pokemon Go a little bit.
Yeah, that was
Yeah. And so now we can see that it's working as well. It's getting the new value of it and reading it from it using this syntax because it's a method. And so you inside of a method, you can get access to your object with this syntax. That's so you've seen before whenever we were writing a string and I wanted to get a variable, read a variable out. I had to do something sort of kludgy like console.log. You guys can start using the syntax if you want because it makes stuff really nice when you're working. But like if I'm going to do the first part of this, I would say like you have hot, and then I need the type, right? So I'd have to do this plus, and it would be like Pokemon.type plus, and some more text in here. In order to sort of get that variable name. And the reason I have to do that is because inside of a normal string, JavaScript doesn't try and interpret variable names. It doesn't look for any variable name. It just prints out that string, right? So that's why you'd have to do this, because otherwise, if I didn't have this sort of separation, you would just get, you've got a Pokemon type because it's not doing any parsing of it, right? It's just part of the string. And that's why we've used this concatenation is what that's called when you've got that plus symbol in between them. But recently with JavaScript 2015, essentially they gave a nice shorthand notation that lets you, if you use this backtick character. So if you look at your keyboard, in the top left of your keyboard, there's something with the little tilde, the squiggly, and then this backtick is what it's called. If you use that around your string when you're writing a string, then you can put like variables directly in it with that $ curly braces syntax, and it will read out what it can. Now it doesn't work for everything. There's only certain types that it can just automatically read out. So like if I had, we have describe, right? So let's say I do this. The describe function it's actually better than I thought. It pretty much gave you the whole body of that function and it spit it back out. Really cool. But I was thinking it would just say like function or something there, right? But it's a shorthand so that you don't have to sort of do all that work. Pokemon. Try. I don't even know what's going to happen here. See there, it just said this is an object. It was like, I don't know how to write this out. You have to tell me what to do to write this into a string. So all I'll tell you is this is an object. An object. But that's sort of what that $sign and the curly braces is there. It's just a way for me to not have to do this plus and into string and do a plus and into string and do a plus to write something out. I don't think I think that's about what I wanted to cover today. We even got to adding methods to an object. I didn't talk about getting the object type. I need to edit that out. So we'll look at that next time. And then we'll start talking about one of the challenges with what we just did is each object that we created is unique, right? We can't, so if we were, you know, Twix or Mars or whoever makes these, or we're Ford, in a sense, Ford doesn't hand make every truck that comes off their assembly line, right? They've got a factory that produces pretty much the exact same truck each time. And they do that so that, you know, it's consistent, it's cheaper, it's fast. That's the magic that Ford created, was the concept of the assembly line to produce the same thing over and over and over again. And so far, what I've shown you for objects, each time we create an object, we have to create it by hand, uniquely every time, and each one is different. So next class, we'll start talking about the concept of how you can create something that will create objects for you of a certain type over and over and over again. So that instead of, you know, we'll basically create something like a car factory, if you will, so that you pass in some information. Oh, I want a black truck or whatever by Ford, and it gives you back that, an object with those properties. It just is always the same. Now, if you want, you can do it one way real fast. I could show you an example of how we could do it, although we're going to show a few different ways, but why can't we just make a function and do that, right? We can make a function to do that. It might take a type and a color and a brand, and it can just return a new object right here with type of type and color of color and brand of brand, right? Because again, that's just key value notation. So our key is type, and then it evaluates the type argument, so it sets it to whatever we call it with. So now if we can call our car factory and create a truck that's black and by Ford, if you will. And now our Ford objects. So, I mean, that's one way we can do something like that. We'll show you some other ways and why there's differences and other ways to do it. But hey, now we can create vehicles with a little factory. Boom, 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 boom. Spit out vehicles that all will have the same set of properties on them. I think that's about it for today. If there's any questions, I'm going to go ahead and shut down the stream. And then if people have any questions,